Yeah, the recording screwed up in the last class. Didn't get the last like 5 minutes. So while you're doing the warm-up problems, which there are 3 of them, I will remind you that tomorrow is NTC's registration day for the class at NTC. So if you have an NTC ID, please bring that with you tomorrow. If you don't have an NTC ID, or if you've not registered for a dual credit class yet, you need to bring your social security number tomorrow to class with you so that you can get registered in the class. Yep. What was the other thing? There were 3 things that I was supposed to remind you of. So there's that, and then there is a video that you're going to have to watch between today and Tuesday's class, and that's on Canvas. It's posted on Canvas for you to watch and take notes on. And I can't think of anything else to remind you of. So 3 warm-up problems to do if you haven't done them yet. Please do them now. So number 1 is asking how many radii get us an arc length of 50 meters, because that then tells us how many radians we have for a central angle. So really what you're doing there is you're just dividing your arc length by the radius. So that's going to be 50 divided by 12.5, which should then get you 4 radians. Questions, comments, concerns, clarifications? It is. Radian is the angle measure. Radius is a length.
Yeah.
Yep.
Should we do 4 rads?
You could do 4 rads. You could do 4 with a little r. All those are the same. Okay. Then it said we need to convert, in here in number 2, we need to convert that into degrees, minutes, and seconds. So I know for sure that it's going to be 178 degrees. I need to look at the 0.65, and I need to multiply that by 60. When I do that, I get 39. So that tells me then that this is 178 degrees, 39 minutes. Those of you that weren't here yesterday because of PSAT for that video is posted on Canvas for you to watch and learn how to convert decimal degrees to degrees, minutes, seconds, or, like in number 3, convert it back into decimal degrees. So that's going to be 67 plus 45 parts of 60. I'm going to add that to it. Plus 58 parts of 3,600. So now they're all in degrees. Okay. A minute is a 60th of a degree, and a second is a 3,600th of a degree. When we add all those up and we round to 3 decimal places, I get 67.766 degrees. Questions, comments, concerns, clarifications? The mathematical relationship that we have going on betwixt our three variables in a circle. Between arc length S, central angle theta, and radius r is the arc length is equal to r times theta. There is one caveat, condition, if you will, to this particular formula, and that is that our theta, our central angle, must be in radians. If you are going to use this formula, your central angle theta has to be in radians. Can't do it if it is. Okay? So if your angle that's given is in degrees, you first got to convert. If the answer that you're looking for needs to be in degrees, after you get the radians, then you got to convert it to degrees. Okay? But if we're utilizing this formula, we've got it. That central angle has to be in radians. Okay? A circle has a radius of 12 centimeters. A central angle theta intercepts an arc length of 18 centimeters. Find the radian and degree measure, so it's asking for both, of theta. Well, we can utilize S equals theta r, or r theta, I should say. Wrote it different. For some reason, in the last time, I was going theta r. R theta. We know that our arc length is 18 centimeters. We know that our radius is 12 centimeters. They're in the same unit. That's good. And we just need to find theta. So how am I going to solve that for theta? Divide by 12 on both sides. If I divide by 12, I get my radian measure for theta, which is 3/2. Let's see. I would accept 1.5 radians there, too. Okay? Then it asked us to convert that into a degree measure also. So I need to take 3/2 there, and I need to multiply it by, to go into degrees, that's going to be 180 degrees over pi, which is going to give me 270 over pi degrees, if I wanted it to be exact. If we're decimal approximating it, 103, so it's probably gonna be less than 90. What do we got? 85.944. Okay. Try that one. Central angle of 2.15 radians. Is that good for this formula? Or do I need to convert? Good, because it's in radians. Okay. So that's going to be 2.15 there. My radius is 8. That's going to go there. 8 times 2.15. I'm going to go with 7.2. 17, yeah, sorry. 17. I've got to carry the 1. Inches is my label. Questions, comments, concerns, clarification? Find me this one. So I'm going to use S equals R theta. Can I use 60 degrees?
No.
Okay, no, can't use it. So I got to convert it to radians first. So I've got 60 degrees here times, I'm going to go with, I want it in radians, so that's going to be pi radians over 180 degrees. So that ends up giving me pi over 3. That's my radian measure. My radius is 9 inches. So my arc length here would be 3 pi inches. If I convert that to a decimal equivalent, I don't know why you would, because 3 pi is such a nice, clean answer. 9.425. Okay. Before we start this one, Rose, can you explain to the people in the room how a track works? Because you're a track athlete, aren't you? Okay. Are there 4 corners in a track, or are there 2 corners in a track? There's no corners? You don't call it going around a corner? What do you call it then? A curve? Okay. Are there 4 curves, or are there 2 curves in a track? There's 2 curves, right? So when we say here has running lanes, how much longer is than the we're talking running lines, right? Okay. So that means we're going all the way around, right? A curve, okay, is how many degrees then? Will be half of the circle, right? So that'd be 180 degrees, right? Or if they convert 180 degrees, just pi radians, right? Okay? Because 2 pi goes all the way around, so half of it would be pi. Okay? So let's talk about the inside of lane 1. Okay? So the inside of lane 1 would be like that. Agree? Okay? It's got a radius of how much? Radius of inside of lane 1. Literally written in the problem.
33.
33 meters. Okay? We said that our theta was how much? Pi. Theta is going to be pi there, because if we want to use S equals R theta, then we've got to have 33 times pi. So that would give us the inside of lane 1 then would be 33 pi meters long. Agree with me on that. Okay? That's the inside of lane 1. Each lane is 1 meter wide. Roughly true? A little bit more than that. Actually, a little less than 50. Okay. Okay. So now let's talk the inside of lane 5. So here is inside of lane 1, right? Okay. A little purple. Here is the outside of lane 1, or the inside of lane 2. Here is the outside of lane 2, or the of lane what? 3. Sorry, I didn't hear you say 3. Okay. Outside of lane 3 is lane 4? The inside of lane 4. You forgot that key word. Okay. The outside of lane 4 is also the inside of lane 5. So we don't have to go any more lanes, right?
No, but there's a 4 on the outside.
We're not looking for it. We're looking for the inside of lane 5, which is the outside of lane 4. Okay? So we said that this distance here was 33, because that's what we just said over here. So then if I add, now what's my radius? 34. Now what's my radius? 35. Now 36. Now 37. So this one has a radius of 37 meters. Still going pi radians? Yes or no? Yep, still going pi radians. Okay. So what is the arc length of inside of lane 5? 37 pi meters. Okay? So how much longer is the inside of lane 5 versus the inside of lane 1? 4 pi? So it's 4 pi meters longer, which is approximately
12.566. Whoa.
Huh?
Is he lying to us?
Huh? Was I lying? Alright, so, again, a couple of reminders. First off, I'm going to give you a worksheet now to be working on that will be due the day of the test. We still have not established what day that test is going to be, but just so you are aware, Chapter 4, we call it Chapter 4, is from our old textbook. Okay, so let's say our old textbook was this thick. Okay, chapter 4 takes up that much of that textbook. Okay, all right. Okay, chapter 4 is like all of the trig stuff. So we will be on chapter 4. I use quotation marks for that one. We'll be on chapter 4 for about 3 months. Okay, we are not doing a chapter 4 test. Okay, no. We break this up into mini chapters. So section 4.1 of chapter 4 is the test. So you will have a quest, if you will, a little bit shorter than a test, a little bit longer than a quiz, a quest. Okay, you'll have a quest on 4.1, probably, maybe. I don't think we are ready for it yet on the 24th, but it might be the first week of November. Okay, right? So there's that. On top of all of that, there is a video for you guys to watch sometime between now and Tuesday's class. Okay? I'll wait, but everybody can hear this because God forbid I say this and everybody's talking and then comes Tuesday, doesn't understand why they don't know what we're talking about. So are all the side conversations done? Good, because I literally have 30 seconds worth of talking to go. Okay? There's a video to watch on Canvas. It's posted already. You can watch it right now. You need to watch it at some point in time before you have class on Tuesday. It's going to go through the 3 different types of speed that we are going to start discussing on Tuesday. Okay? So you can choose not to watch it. You can choose not to take notes on it, but then you will be lost on Tuesday. And the first question I will ask you is, did you watch the video? And if you say no, sorry. Okay? Your own fault. We're giving you 4 days to get it watched. Okay? It's only it's less than 10 minutes. So, if you want to watch it now, you can. I remind you again that NTC registration is going to be tomorrow. So you need your NTC ID number or your Social Security number if you haven't registered yet. Okay?